Hello, welcome to part 1 of step 20. In this step, we're going to talk all about similarity. So step 20 says I can identify similar polygons, angle, angle, side, 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 angle, side, similarity, and the parts of similar triangles. So this is in chapter 7, sections 2, 3, and 4. So part 1, we're just going to cover section 2, which is just kind of describing what a similar polygon is and starting to match up the corresponding parts. So similarity is very close. It has a very close relationship to congruency, which we covered. It's technically chapter 4 in the book. So you're going to see some things that are similar, but other things that are different, obviously. So for similar polygons, these are when we had our dilations. Okay, remember dilations, we were changing the size. Just like if you go and get your eyes dilated, your pupil expands or contracts. So these are similar polygons. Okay, so what happens, just like when we did our dilations, the angles are all going to stay the same. So the corresponding angles are congruent, but the corresponding sides are what we call proportional. If I could spell. Okay, so to kind of give you a little glimpse, if we compared congruent things and similar things, you're going to see some similarities or things that are the same. So in congruency, we had to have all corresponding angles congruent. And the other thing was all corresponding sides congruent. So similarity starts out the same way, all corresponding angles congruent, but instead we have all corresponding sides are proportional. And this happens because they have the same scale factor. So are proportional by the same scale factor. So you're going to hear me as we practice this, remind you what proportional means through all of this. So going back to this little chart, we could write all of the corresponding angles as A goes with A, B, or A goes with W, B goes with X, so on and so forth. And then all of those corresponding sides, instead of writing them congruent like we did in our congruency, we're going to write them proportional to each other, and they should all work out to be with the same scale factor. The other thing is, obviously, congruent was our squiggle with the equal sign under it. Similarity is just the squiggle. Notice it's right here. So you see that squiggle? It means they are similar. So just like we started out in congruence, we're going to do the same thing, writing out all the corresponding angles and all the proportional sides. So the big thing is we have this similarity statement here. Okay, and they work the same way that the congruence statement. So this first letter, F, should go with the first letter, J. So we could mark in our picture, angle F is congruent to angle J. We could put that with one arc. Okay, G is second, K is second, so we can go ahead and mark those with two arcs. And then last but not least, H and L should go together. So we could go ahead and write out all the angles. So we could say these are our congruent angles. So angle F is congruent to angle J, angle G congruent to angle K, and H congruent to L. Okay, so nothing's changed so far with congruence. The next part is where we're going to change. Instead of writing our our sides congruent to each other, we're going to write proportional sides. So this one gets a little tricky when we want to label it because we can't label it as our little tick marks because they're not congruent, and the tick marks mean that they're congruent. So this would be an instance where I would say let's highlight them. And then that way we know that they kind of go together. We're sort of color coding, but we know that they're not congruent. So if I went from F to G, I went from one arc to two arcs, I would go J to K. So this would tell me FG is proportional to JK. All right, then I'm going to go G to H. So 2 tick marks to 3 tick marks. I would go K to L. So I said GH over KL. And last but not least, H to F, 3 tick marks to 1 tick mark. L to J. H to F, L to J. So as you do these, I did want to make one point. So the letters have to stay in the same order like we wrote our congruence. If anywhere you see an F, you're going to see a J. Anywhere you see a G, you're going to see a K, H, and L. They always go hand in hand. But you could switch these proportions. If I wanted to do the bigger triangle over the smaller triangle, that's fine. You just have to be consistent. You can't say like FG over JK and then KL over GH. It always has to go smallest over biggest or biggest over smallest. Okay, so in this example, so we've taken our red photo and we've made a dilation to it into the blue and into the green. Remember, when we have dilations, we have to multiply by the same scale factor. So if we multiply by different scale factors, the picture is going to be distorted. So in this, they're all rectangles, so we could say that this is 10 inches, 8 inches. We can label everything. We don't have to do all the sides for these because their opposites are congruent to each other. But you get the idea. So if we were looking at our blue rectangle, the first one we would want to say is, are the angles congruent? And we could say yes, because since they're rectangles, all the angles in all these figures are 90 degrees. So we could answer that for the second one as well. So we have half the battle. We know that all the angles are the same because they're all right angles and they all have to have a matching pair. The next thing we have to ask ourselves is, are the sides proportional? Okay, and we have to check both sets of sides. So if I was saying, and it's really up to you how you want to do this. If we want to go red over blue, that's fine. Or you could put blue over red. It really doesn't matter. But if I said AB from our red, I'm saying the top, like above the dog's head. So A to B would have to correspond with EF, which means AB was 10 and EF is 14. And if we simplify this, we could take a 2 out, so 5 over 7. Okay, so if these are proportional, my next ratio should work out the same way. So remember, I said the red one over the blue one. So I'm going to say BC. So that right-hand side should go over FG. So 8 over 12. Okay, 8 over 12, you could take a 4 out. So that would be 2 over 3. So 5 over 7 is not equal to 2 over 3. So our sides were multiplied by different scale factors. So these sides are not proportional. The blue figure is distorted compared to the red figure. So if these don't work, sides are not proportional. And photos are not similar. Okay, so that's the biggest thing. Oh, not proportional, so they cannot be similar. Okay, but if we look at the green one, we could do the same thing. Let's look at the top, AB. Oh, yes, I should write it out. So AB should go with JK. So 10 over 15. Take a 5 out, so 2 over 3. And then KL is going to go, oh, no, see, I made a mistake. I wanted to do the big one over the small one, and I can't do that because in my first ratio, I did the small one, the red one, over the green one. So I have to say BC over KL, which is 8 over 12. Again, take out a 4, so 2 over 3. Okay, so 2 over 3 is equal to 2 over 3, obviously. So we would have sides proportional. So since angles are congruent, sides are proportional, these are similar, and we would be able to write a similarity statement. I could say, remember, when we're naming polygons, especially rectangles or any other polygon, you have to rotate all the way around. So if I said A, B, C, D, I started in the upper left corner and I rotated clockwise. So in my green one, upper left corner would be J, then K, L, M. So I would say similar to J, K, L, M. And it asked for the scale factor, so our scale factor is 2/3. So that's how the polygons are congruent, and that is our scale factor. So we're going to do something similar here, except we know that they're similar to each other. Okay, so for our first one, we know that ACDF is similar to VWYZ. So if we wanted to find X, X is down here at FD. If I look, F and D are the last two letters of my similarity statement, so these should go with YZ. Okay, so I know that half of my similarity statement should be FD, or I'm sorry, my proportion, FD over ZY. Okay, but we need two sides of a proportion in order to solve it. So now what I want to look at is, do we have a side that matches with, or it's just numbers, we don't have variables. So if I look at WY right there, it only has numbers. So WY, our middle two letters, should go with CD, which also only has a number, which works out then. So I said FD, so I'm going to say CD, and that's going to go with WY. Once I have my proportions set up, I'm just going to plug in the values. So FD is labeled with X, ZY is 10, CD is 9, and WY is 6. Okay, once I have this set up, all I have to do, if you remember how to solve a proportion, is we cross multiply. So I'm going to do X times 6 and 10 times 9. So X times 6 and 10 times 9. So I have 6X equals 90. Divide both sides by 6. X equals 15. Okay, and I'm going to do the same kind of thing, but this time I want to find Y. Okay, Y is sitting over here at ZV. ZV is the first and the last, so that should go with AF, which is 12. So I could say ZV over FA. Okay, and again, I need a second side to my proportion in order to solve. And we can always just refer back to the purple ones because those ones we knew had numbers, and then we can solve. So let's use our CD over WY again. And then from here, we are just going to plug everything in. ZV. Oh, I made a mistake. Okay. See, what I did is I took ZV and put it on top for the first one. Well, I need to switch my proportion because I didn't, I flipped it the other side. So I want to put WY over CD. So ZV would be 3Y minus 1. FA is 12. WY is 6. And CD is 9. Alright, so I have my proportion set up, but this time it's going to get a little more complicated when I cross multiply. When I do this piece, I need to do 9 times the entire top. So I need to do 9 times 3y minus 1, and then just start 12 times 6. So I need to distribute this in. 9 times 3y would be 27y minus 9, and 12 times 6 with 72. All right, and then I could solve this. Plus 9 plus 9. 27y equals 81. Divide by 27. Y would be 3. All right, we're going to cover one more thing, and then I'll wrap up the video. So the other thing about perimeters of similar polygons is that their perimeters are also proportional. Perimeters are proportional, okay? And they're actually proportional by the same scale factor. So if you forgot perimeter, you add up all of the sides. Okay, so it's probably going to be easier to explain this one as we do an example instead of just reiterating it. So the big thing in this example is that ABCDE is similar to PQRST. So we know the scale factor should be the same amongst all of our sides. So if we take a second, we have some stuff labeled, but not everything. So notice AB and BC both have 1 tick mark, so they're both 8. AE and CD both have 2 tick marks, so they're both 4. And then if we look at our other piece, RS, how many is that? 4 tick marks. So PT should also be 3. So we need the scale factor and we need the perimeter of each polygon. Well, in ABCDE, we have all the sides, so we could find that perimeter. So perimeter of ABCDE should be 8 plus 8 plus 4 plus 6 plus 4. And if we add all of that together, we get 30. Okay, so we have one of the perimeters. We still need to find the scale factor and the other perimeter. Well, if they're similar, all of these sides should have the same scale factor. So we could say that the perimeter of ABCDE is proportional to the perimeter of PQRST. These perimeters are proportional by the same scale factor as the sides, so then we could match up a set of sides. So we could look at AE, and A to E should go with PT. So I could say AE over PT. Then we could plug what we know in. Perimeter of ABCDE is 30. We don't know the perimeter of PQRST, but I'm just going to say that's X for now. AE is 4 and PT is 3. Okay, then I'm going to cross multiply. 4 times X equals 3 times 30. 4X equals 90. Divide by 4, divide by 4, X is 22.5. So, now we have the perimeter of PQRST, the perimeter of ABCDE. We just need to find our scale factor, okay, which we can take AE over PT, which was our 4 over 3, or you could say 3 over 4. It's the same thing. It just depends on how you write that ratio. So, putting everything together, perimeter of ABCDE is 30. Perimeter of PQRST is 22.5. And our scale factor is 4 over 3, or 3 over 4.